Okay, let's try this. Hurrah! It seems to be working. So I'm gonna close out of other things. Try and free up my network a bit here. Okay. Yeah! So we are live. That is a surprise. Hi guys, it's Acorn. This hasn't happened in a while. So I'm live, and I was mainly going to do this for a test stream, but like, why not? I'm showing off a new system that I never thought I'd show off. Don't actually know what the quality of this stream right now is. Let me see. Yeah, I put like a 30-second delay on it because otherwise my network would crash too often. Okay, let's switch over to my USB cam. Hi, it's Acorn. I am currently showing off a new system I'm developing called the SirenPi. So, if you don't know what this is, which you probably don't, can barely see this. Sorry about that, my lighting is horrible. This is a Raspberry Pi board. This specific board is a Raspberry Pi 3 Model B. I have 3 of them because they're super cheap, and I had the opportunity to get some for so cheap that I didn't have to pay anything for them. But I have currently 2 of them. You can actually not see either of them. Yeah, they're over here. Here's one. This is actually the SirenPi. I don't have it hooked up to a speaker right now. So there you go. This is the SirenPi over here. You can barely see it. And what this one does is, whoop, yeah, that's the screen for the other one. What this one does is, this one is a siren. It has a whole bunch of audio files loaded onto it, and on request of what I call the bass Pi, which is actually up back up here, you can probably not see it. Yeah, you can barely see it. It's this floating looking thing back here. You can see the light on my hand. This is the bass Pi, and this communicates with the SirenPi. I'm actually building a federal signal modulator frame for this SirenPi, and I'm going to get a couple amplifiers and speakers, and yeah, so this thing's gonna go in a frame, and it will be in a waterproof sealed container outside, and they communicate over the internet, so this one can be inside and hooked up to a monitor and everything. Oh no, I'm dropping frames. Why you do this? Like, what'd I do to you? Stream complete. Okay. What is going on here? Let me close out of different tabs. All these. I dropped a lot of frames. I don't know why. So, we are live SirenPi. I don't have it hooked up to a speaker right now. So there you go. Okay. hopefully this is working now. So I'm going to demonstrate this SirenPi system. Yeah, hopefully this is working. I don't know why it dropped so many frames. Looks like it's stable now. So you might have not heard me. This is the SirenPi, and it communicates over internet to a Raspberry Pi back there called the base station Pi. And it communicates very simply. Over here I've got a terminal in this Raspberry Pi thing. You can see it's this black box. And I've just got to run this Python script I wrote. And it does some crazy stuff. It's now telling me the active IP of the siren, which is of course closed loop because I don't want to be broadcasting siren access to the internet. And it gives me the status of the siren and everything else I need to know. So right now it's giving me the IP, the port, and the fact that the siren isn't doing anything. It's standby. And upon running a command, it's very simply period to enable the siren, and let's do the chime test. So 1. 1 is the command for siren, and period is the command to tell the siren to activate. So period 1, I click enter. You could probably not hear that. Let me bring this over here. Oh, you can see that blue light right there is actually my base Pi receiving data from the SirenPi. Let's see if this can hear it a little better now. I wish I could like turn on. You can. This over here is a SirenPi. Uh-oh. Light flickered. Oh. So I haven't lost connection yet. So if you actually watch back here, up around here, that is my base station Pi. It's really hard to see, and I'm sorry about that. I don't have a good camera or good lighting in this area. But upon running this command, I'm gonna put it into steady mode. Period 3, which is steady mode. Let me check. Okay, screen does work. Period 3, which is steady mode, and I click enter. It will send the data to this Pi completely remotely over the internet. For example, the only cables going into this Pi right now is power and the speaker line out. Nothing else. So upon running this command, this will transmit data over the internet. And actually, while it's transmitting, you might not be able to see it because this camera is not so good. But there would be a little flicker of an orange light and then a bright blue light as this transmits telemetry data back to that Pi, telling it what it's doing, how long it will be doing it for, and basically that's it. So as soon as I click period 3, you're gonna watch. You could briefly see a orange flash, and then there's a bright blue flash, and now this is in steady mode. I don't know if you can hear that. Hold on. I can get it closer by unplugging the fan to the base station Pi for a brief second. Plugging it back in. Don't know if you can hear that. Maybe very briefly. Okay. And then if I do period 0, which is the cancel command, there's an orange flash telling it, saying that it transmits the data, and as soon as it's done doing the action, there's a blue light saying that it's receiving data, which is saying siren status inactive, cancelled. And there's also a glitch, but it should also say that the siren status after it says cancelled goes back to standby, but it doesn't do that. It's just a glitch in the program on this guy. The base station Pi's program is essentially finished. This one I'm going to add an LED support, but I actually don't have any more LEDs, so that became an issue. Here, I'm actually going to put this up over here so you can actually see the red light to see that it's on. I actually don't know if the red light's a good thing. I think it means that it's underpowered, but I don't know. Yeah, so I actually haven't dropped any frames since that first issue. So, we are now going to go through all the options. So, with this keyboard right here, I'm going to go through all the current configurations. So, whenever you send data to this Pi, you will always have to click period before sending data. Period is the activation code. And I can change it up, so you could have the activation code be like, this is the activation code, or it could be like a 24 character string, as long as that activation code comes first and then the code to enable the siren comes next. Right now I just have it period so I can use this number pad, but in the future I'm actually going to completely control this system via DTMF, which is actually how your phones communicate, or used to. I don't know if they still do. They probably do. Somebody correct me if I'm wrong. It's how phones communicate data. So all those numbers would be communicated via DTMF over the air to a cellular tower, and that's how your phones can call other phones. Right now it's all like digitalized, but oh, it's receiving data. Oh, it's saying it's standby. Huh, I've never seen it do that. Apparently this guy has some error correction then. Yeah, whenever you see a blue light up there, it means it's receiving data, and whenever you see a orange light, that means that it is not receiving data, but it is actually transmitting. I plan on, in the future, setting everything up so this, because right now this has MP3 files, it's got WAV files, .wav files loaded onto it as the siren audio. And upon issuing a command, let's say .2, which is whale, actually I'm gonna do 9. It's got 9 commands in it. So if you do a command like .9, it tells the in the program that is on that Pi, it reads the data and tells it what command to do. And in reading these commands, it can actually work out what it wants to do. So if it reads .9, it knows that 1 does this, 2 does that, 3 does that. It'll go all the way through all the different commands it can do until it reaches 9. And it reads, I think that is pulsed whale. Yes, that is pulsed whale. And upon reading pulsed whale, it executes the code for pulsed whale. But right now it's only playing a WAV file, which actually becomes, I'll show you the issue that happens whenever it comes to that. But in the near future, I'm going to implement it actually on chimes in a little bit. I will be implementing a system to allow it to actually generate the tones via software. So instead of playing a WAV file, it will actually generate the tones from software, which will allow me to do more system, like, right now, one of the issues is if you cancel, mainly with whale, if you cancel the audio, it will actually sound really glitchy, because it will be playing that tone that rises and falls, and like in the middle, it will just randomly cut to the very highest tone it can play and just fall if you cancel it, because it plays this falling tone for a cancel. If I am generating the sine waves that it plays real time, I can have it constantly monitor the frequency it's on, and have a start frequency and a stop frequency and a high and low frequency. And if I want to cancel, I can say just go to the lowest frequency no matter what frequency you're on, and then stop playing audio, and it will just do that. An issue, and I can also give it a time frame for a certain frequency. So if it's at the highest frequency, go to the lowest frequency within 5 seconds. Or if it's on the lower frequency, just stop playing. So, yeah, so I can do something like that. Or I can give it a time that it can actively change the frequency. But I don't know actually how to change that, so if anybody has any ideas on how to actively change a sine wave while, like, in a program in Python, please hit me up. I would gladly appreciate the help. Other than that, I'll play a pulsed whale, which is .9. It's receiving data. Oh, it said it is invalid. Huh. Let's try that again. There it goes. Now it is playing post whale. And you can see that it stopped receiving telemetry data. And if I do .0, which is cancel, sent the data. And receives data. It's very efficient, and it works fairly well. Let's see how long it takes. It tends to receive data for a very long time. Oh wow. Did the program break? Oh, there it goes, it stopped. Oh yeah, and here, I'm going to play whale so you can actually hear what it does wrong. If I play whale, which is .2, I don't know if you can hear it, but it's doing the whale siren sound. But if I cancel it, it sends the data. Oh wow, it actually worked for once. It will actually tend to cut it in the middle, so it'd be boo, wee. If you nail the timing, it sounds pretty good, but you have to nail the timing. Yeah, so that's the little system I've been working on. I have some other boards like this and an Arduino Uno that I'll be working on implementing. This is a Spark Adafruit Circuit Playground board. Looks little something like that. So, yeah. Okay. Well, thank you for watching this screen test. You didn't need to. If you watch it, thank you, and I'll see you next time, I hope. Let's send it off with a chime test. You probably haven't heard any of that, have you? Well, see you next time.